Good evening, sir.
Good evening, sir.
Good evening, everyone. Join quickly. Just we are starting. Just in 1 minute, we'll be starting. Let everyone join.
Good evening, sir.
Okay, now so welcome all. Now we can start with the class. In physics, we were doing about electricity. So, but before that, I told you that today we'll be doing on with the revision of human eye and colorful world. So there are some important topics which will be discussed from human eye and
Good evening,
colorful
sir.
world. Okay. Okay, so before I start, is there any doubt to anyone from human eye and colorful world?
Sir, about atmospheric temperature, sir. The twinkling of stars.
Okay. Okay. Any other doubt? Okay, let's start with we'll try to understand human eye and colorful world, but generally right now I'll be not going into human eye. I'll be just discussing with the colorful world. Right?
Sir, can you explain the numerical part?
Okay, you want human eye again to be explained again? We'll be
Yes,
doing
sir.
human. Okay, human eye will be doing after we complete this colorful world. Okay, let's try to do this colorful
Okay,
world
sir.
first. Okay, so first we try to understand the electromagnetic spectrum. So see, electromagnetic spectrum. Electromagnetic spectrum, when I say electromagnetic spectrum, it is actually I'm referring to light. When we say light, so for the common people, light means only the white light. When I say white light, that means the light which causes vision, which causes sensation of sight. So that we call as the white light. But when we are talking of electromagnetic spectrum, it considers all the light means, as we know that light is an electromagnetic wave. So all the waves which are electromagnetic, they constitute the electromagnetic spectrum. Okay, so in the electromagnetic spectrum we observe gamma rays, then we have x-rays. After x-rays we have uv rays. Then after uv rays you will find our visible spectrum, which we call VIBGYOR. Then after our VIBGYOR or visible spectrum, we find infrared waves. Then after the infrared, you find microwaves and radio waves. So you have microwaves and then you have the radio waves. See, all these waves, they are the spectrum of electromagnetic waves. They are electromagnetic waves. If you see gamma rays, X-rays, UV rays, VIBGYOR, which we call as the visible spectrum, this is what we call as the white light. So in this chapter, we are mainly interested with the VIBGYOR. Okay. but we are just getting that everything here is a electromagnetic wave. So gamma rays are also electromagnetic, X-rays are also electromagnetic, and all these light rays, all of them are light. So all these light rays, they travel with the speed of light. So the speed of all these waves is c. In vacuum, their speed is c, and this c can be written as c equals to f lambda. I think everyone is aware of the formula that the wave speed. Okay, so wave speed v is given as f lambda. So here c is the speed of light, f is the frequency of that light, and lambda is the wavelength of that light. Okay, so since the speed is constant for all of them, that means there will be a variation of frequency and wavelength. The light which will have a higher frequency will have a lower wavelength, and the light which will have a lower frequency will have a higher wavelength. If we understand in terms of frequency, so our gamma rays have the highest frequency. They have the highest frequency. And the radio waves, they have the least frequency. If I discuss in terms of wavelengths, so gamma rays, they will have the least wavelength. And radio waves, they will have the maximum wave. Okay. So red color has the maximum wavelength, and gamma rays, so not red, the radio waves have the maximum wavelength, and gamma rays have the least wavelength. And everyone understood about this wavelength and the frequency?
Yes, sir.
So you can consider that this side you have the frequency increasing. Here we have frequency increases from radio waves to gamma rays, and here we have wavelength increases, lambda increases. In terms of lambda, if I discuss about the Vibgyor, so okay, out of these light rays, I think Siddharth, Siddharth.
Yes, sir.
So I think there is some TV or something voice coming up. You can just check it out. Okay. So you have gamma rays, X-rays, UV rays, Vibgyor, infrared, microwaves, and radio waves. So gamma rays, they are high energy radiations. They are radiations which have a high energy, and hence they can penetrate certain substances to a certain millimeters. X-rays, they have energy lower than the gamma rays, and they are used in medical sciences for detecting the internal organs of the body. Like they can be used to detect the fractured bones and other cases where we use the X-rays.
Gamma rays.
X-rays, not gamma rays.
Okay.
Gamma rays are harmful, and they are highly gamma rays. They can cause skin cancers to a high extent. So we generally don't use gamma rays. Even X-rays are also harmful. So that is why we generally don't try to be exposed to the X-rays. It's done only when it's required. Okay. So X-rays. Then we use UV rays also to study the internal organs. Okay. X-rays, UV rays, they are used to study the internal organs. Finally, we have the Vibgyor. So our Vibgyor, this is also called as the spectrum of white light. So Vibgyor, which you constitute violet, indigo, blue, green, yellow, orange, and red. So this is our Vibgyor. And when all the colors are combined together, they constitute the white light. So when we say white light, it means the light that we obtain from sun. The light that we are obtaining from the sun is called as white light. It is a mixture of all the 7 colors. Okay, so it is only these colors which are visible and which cause the sensation of vision. The other colors of light, they are not visible or they do not cause any sensation of vision. The infrared radiations, they cause heating effect. Okay. So the heat from the sun is carried to the earth in the form of the infrared radiations. Infrared radiations, they are also used in small point-to-point communications like your remote and other devices. They use infrared radiations. Microwaves, they are used in microwave ovens. They are also the heat waves. Okay. Microwaves are the heat waves. They are used in our microwave ovens for the heating purposes. Then we have the radio waves. So radio waves, they are used for transmission of radio and mobile signals. It's in the same way, you also have long radio waves. So these radio waves, they are used for transmission of signals. So I hope everyone has understood about all the components of the electromagnetic spectrum.
So 1 minute, sir, writing.
Okay. Okay, Siddharth. Siddharth.
Yes, sir.
See, out of the gamma rays, microwaves, radio waves, which one of them has a highest frequency? Yeah, Siddharth.
Radio waves.
Radio waves will have the highest frequency. Yeah, Siddharth, which one will have the highest frequency?
Radio waves.
Radio waves. Okay. See, that is why I tell you to keep your camera on so that you will be concentrating here. Right? Yeah, Abhinav. Abhinav.
Sir, is it infrared?
No, I'm asking in the VibGyor. From the VibGyor, which one has the highest frequency? Which color of light will have the highest frequency?
Red.
No.
Okay.
Violet will have the highest frequency. See, here we
Red will
studied.
have the maximum wavelength, right?
Yeah, red will have the maximum wavelength. In terms of wavelength, violet will have a wavelength of nearly 350 nanometers. Okay. Whereas red has a wavelength of nearly 750 to 800 nanometers. This is the wavelength of red color. Okay. So red has the highest wavelength and lowest frequency in the video or in the visible spectrum. Okay. So Sumukh. Yeah, Sumukh.
Sir.
Which one will have the highest frequency?
Sir, red.
No. Red has the highest wavelength and lowest frequency.
Okay, so violet.
Violet. So that is the thing I want everyone to concentrate because these things are quite confusing. Okay. You
Yes,
can
sir.
remember it like this. See, the thing is very simple. You can remember it like this. Viola has maximum friends. Okay. So Viola means violet, has maximum, and F means frequency. Okay. So out of the VibGyor, if I want to discuss about the VibGyor, so in the VibGyor you will have violet. Violet will have the maximum frequency. Got it? Everyone is clear?
Yes,
Siddharth? Okay. So Siddharth, now it's clear to you that okay, Ionija,
Yes, sir.
which one will have the lowest frequency then?
Sir, red will have the lowest frequency.
Okay. And which color will have the maximum speed in air?
Sir, red.
Okay. Dhriti, which one will have the maximum speed in air?
Red.
Red. Okay. Pranaya, which color will have the maximum speed in air?
Maximum?
Maximum speed in air.
Red.
Red. Okay. Rizwana, which color will have the maximum speed in vacuum?
Red, sir.
Red. Okay. So see, all of you are doubtful here. C is the speed of light. Okay. What is the symbol C stands for? Yes, what does the symbol C stands for? Speed of light. Okay. So all the colors of light, whether it be violet, indigo, blue, green, yellow, orange, or red, whether it be whether the color be whether it be the gamma ray, X-ray, or any of them, whatever color it is, whatever light it is, all the colors of light, they travel with same speed, 3 multiply 10 to the power 8 meter per second in vacuum or air. So speed of light is same everywhere. It's 3 multiply 10 to the power 8 meter per second everywhere. Okay. So if I ask what is the speed of violet, it's the same thing. What is the speed of red? It's the same thing. So can I say that all colors travel with same speed? Yes or no?
Sir,
Yes.
but then if speed increases, then wavelength should also increase, isn't it?
No, there will not be any change in anything. The speed will remain the same. All colors travel with same speed in air. Okay. And speed can't increase more than this. This is the highest speed.
Okay, sir.
So no color of light or nothing can travel faster than this. So all the colors of light will have the maximum speed given as 3 times 10 to the power 8 meter per second. Okay. So in air, all the colors of light, they travel with the same speed. Okay. Now in other media, when the colors of light travel or when the white light travel through other media, so when the light travel through other media, then the different colors have different speeds. Okay. So in any other medium, okay, in other media, different colors have different speeds. So all the colors, they travel with different speeds. They do not have the same speed in different media. So it's like this. Let us try to observe this. What happens over here? We take a triangular prism. So here we take a triangular prism. So this is a triangular prism, and here we take a ray of light. So let us say we take a ray of light which comes and strike this surface of the prism over here. So this ray of light, it contains all the colors of light. This is
Sir, I got disconnected. Like, what happened?
uh, so just see the previous page. Is there anything on this page which you have not understood?
Um, So, sir, I just have like this doubt. So, just in vacuum, the speed is same, but then in different medium, the speed is different.
Yeah, in different media, the different colors will have different speeds. But when the all colors of light, like when the violet, indigo, blue, green, all the colors of light, they are traveling through air. So they are traveling with the same speed.
Okay, sir,
And
got it.
that speed is c, which we call as the speed of light. So all the colors, they travel with the same speed, that is the speed of light in vacuum or in air. But when they travel through any other media, their speed changes. Now see what happens. So here I had a white light falling on this glass prism. Now at this surface, I draw a normal to the surface. So as I know that normal to the surface is always perpendicular to the surface. So here I draw this perpendicular to the surface, which is my normal. So this is the normal to the surface. And this ray of light, it contained all the colors. It contains everything. It contains Vibgyor. Now, when in air, all the colors, they had the same speed c. But when they enter in glass, different colors have different speeds. Like, let us say the violet will have the velocity vv, the red will have the velocity vr, the blue color will have the velocity vb. So different colors have different speeds. So do you think that refractive index will be different for these different colors? Yes.
Yes, sir.
Okay. See, as we know that the refractive index is given as by the formula C by V. So C was same for everyone, but velocity in this medium is different for different colors. So all the colors, they will have their different refractive index, and hence the amount of bending that will be observed, it will be different for different colors. The different colors, they will bend by different angles. So here, my violet, blue, they will bend by greater angles, whereas the red color will bend by the minimum angle.
Now, can you repeat that sentence again?
It will be like this. See, the different colors, they will have different refractive indices. Just 1 minute. Okay, there are 5 messages I couldn't see. Okay. So see, just concentrate here. We discussed that the refractive index is given by the formula C by V, right? So the different colors of light, they have their same speed in vacuum or air. So here all the colors, they were traveling with the speed c, and when they enter in this glass prism, all the colors, they travel with different speeds. So the refractive index for blue color will be equal to c by velocity of blue color. Refractive index of red color will be equal to c by velocity of the red color. Got it? Since the different colors will have different refractive indices, so as per the Snell's law, the different colors will be bending by different angles. Has everyone understood this? So if different colors bend by different angles, so I will be observing the different colors coming out of this glass prism. Okay, so that is called as the dispersion of light. So here we observe that, and finally here we obtain dispersion of light. The different colors, they bend by different degrees. Got it? So the bending of the violet color will be the maximum, followed by the bending of blue, sorry, indigo, blue, green, yellow, and finally the red. Okay, so this is how we obtain here our VIBGYOR. Here we obtain VIBGYOR. You have violet, indigo, blue, green, yellow, orange, and red. Okay, so the seventh spectrum of colors we observe like this. See, violet is written at the bottom. Okay, so violet has the maximum refractive index. Remember our thing here. Viola has maximum friends. Okay, so violet has maximum frequency. Violet has maximum bending. Violet has maximum refractive index. So this statement will help you everywhere. Okay, from this statement you are able to get that violet has maximum frequency, violet has maximum bending, violet has maximum refractive index. Got it, everyone? Okay, so just let me just see how much are you aware, Rijwana.
Yes, sir.
Okay, so Rijwana, out of the 7 colors, which color has the maximum wavelength?
Red, sir.
Okay, very good. So you are aware of the fact, you have not forgotten. So red has the maximum wavelength and violet has the minimum wavelength. It has the maximum frequency. Triti, which color has the maximum refractive index?
So,
Which color has the maximum refractive index? Out of the 7 colors, which color has the maximum refractive index?
violet.
Yeah, violet has the maximum refractive index. It bends the maximum. So violet has the maximum refractive index. Okay. Which color has the minimum refractive index?
Sir, red.
Red.
Hmm?
Red.
Red, sir.
Red, sir.
Yeah, so red. Got it now? So this phenomena which we have drawn here, this is called as dispersion of light. Okay. So the dispersion of light, it means splitting of white light into its constituent colors.
Sir,
Yes.
like in glass, which color has the most more speed, sir? Which color has the maximum speed?
The one which has the least refractive index. Red.
Red. Okay, got it, sir.
Okay. So in glass, red will have the, see the red will have the minimum, red will have the maximum speed. So that the ratio of C by B will be less, and hence it will have the least refractive index, and hence it is bending by smaller angles. Got it? So dispersion, it is the splitting of white light into its constituent colors. Now, can anyone tell what is the cause of dispersion?
The difference in speed because of the refractive
Density.
index.
Yeah, just pardon one person.
Difference in speed of light and density of the medium.
No, different colors of light. The reason is that different colors of light travel with different speeds. In different colors of light travel with different speeds in medium other than air or other than vacuum. So different colors of light travel with different speeds in glass or any other medium. any other medium other than vacuum or air. So now everyone has understood why the dispersion occurs. It's because all the colors, they are having different speeds. So they will have different refractive indices and hence they will bend by different angles. Got it? Any doubts here for dispersion of light? Anyone who has not understood how the dispersion occurs? Yes? Okay, so everyone is clear? Dhriti, Uriya, Sumukh, Siddhisri and Moksha. Okay. Okay. So I think, okay, now let us see another thing that we call as the recombination. Okay. So next we will see the recombination of light. Okay. So let's see how do we obtain the recombination. So the problem is that once the dispersion has occurred, is it possible to recombine all the colors of light to obtain the white light?
Yes, sir.
Yes. So how is it possible?
By adding another prism.
By
Okay.
adding another inverted prism.
Very good. So if I add, let's say I have this one prism and here I add another prism which is inverted like this. So the first prism will be causing dispersion of light and the second prism will perform the recombination. Right? So I'm just showing here two colors, how the two colors bend, and finally we obtain here again the white color. So here we have got okay. So when all these colors they fall on this prism, they recombine. They combine again, giving rise to white light. So here again you will obtain a white light obtained from the second prism. So this situation is called as recombination. Now can anyone tell why dispersion occurs through a glass prism and not through a glass slab? Yes, can anyone answer? No one? Sumukh?
Sir, because of the two refracting surface are parallel to each other.
So what happens by that?
The
The
difference in
refracting rays will disperse.
angle of deviation.
The difference in?
Angle of deviation.
Okay, so your answers are correct. Here you can write that a glass slab can be supposed to be made up of two prisms where the opposite faces are parallel to each other, and hence if one of the face performs the dispersion of light, the second face performs the recombination of light. Got it? Okay. So I expect everyone to write this answer properly. Okay. Everyone should be writing this answer properly, and I'll be checking this in your next class about why dispersion occurs through the glass prism and not through a glass slab. Okay, which color has the maximum bending?
Violet.
Violet.
Yeah, violet has the maximum bending. And which color has the minimum?
Red.
Also, is it possible for us to combine all the colors of light and obtain a white light?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So today we have completed the phenomena of dispersion of light. Okay, can you explain any one natural phenomena based on the dispersion of light?
Rainbow.
Rainbow.
Okay, rainbow. So in rainbow formation, it is the same dispersion that occurs. So in rainbow, if I explain the rainbow, so in rainbow you have the formation of so in rainbow again we observe dispersion of light. But along with dispersion, there are various other phenomena also. Like over there, we observe refraction and reflection also occurring. So refraction or reflection also occurring. Right? During rainbow formation, the phenomena which are there are dispersion, refraction, and reflection. Got it? Okay, so bye everyone. In the next class, we will see scattering of light. Okay. Goodbye all of
Okay,
you.
sir.
See you
Thank you,
again.
sir. Bye, sir.
Thank you,
Bye.
sir.
Bye, sir.
Thank you, sir. Bye, sir.